Hey guys, so today we're going to start a playlist for Pearson Edexcel International Advanced Level Exam past papers. This is going to be the January 2024 paper 1. In this playlist, you will find all of the past papers for Pearson Edexcel International Advanced Level. And through these past papers, we're going to discuss each topic in depth so that you develop better understanding and you're more confident about your exam prep. So let's start with this and see what type of topics you can get and what is the difficulty level. First question is about integration. So integration is basically the opposite of differentiation, and you were introduced with the concept of differentiation in your IGCSE. So in order to integrate this expression, what we will do is first we'll expand the bracket. So you know expansion of triple brackets, you can start with expanding the first two brackets or the last two brackets and then multiply it with the other one. So if I start with expanding the first two brackets, that's going to be 2x times 3x. 2x times 2, then negative 5 times 3x and negative 5 times 2. So that's going to be 6x squared plus 4x minus 15x and then minus 10 times 2x plus 5 as it is. Collect the like terms, so 6x squared minus 11x minus 10. Now we expand it with the third bracket. So that is going to be 6x squared times 2x, which is 12x cubed. 6x squared times 5, 30x squared. 11x times 2x, negative 22x squared. Negative 11x times 5, negative 55x. Negative 10 times 2x, negative 20x. And negative 10 times 5, negative 50. Collect the like terms again. So 12x cubed, then plus 8x squared minus 75x minus 50 dx. Now we will integrate this expression. Always expand the brackets, always simplify your expression. If there's a power in the denominator, bring it in the numerator. Make it easier for you to understand the question and then start solving it. So now integration, what we do is we do the opposite of differentiation. If you remember in differentiation, we would bring the power down and then subtract 1 from the power. So now over here, we're going to add 1 to the power and then divide the term by the new power. Once again, we add 1 to the power and then divide the term by the new power. So it's going to be 12x to the power of 3 plus 1. I added 1 to the power. And then I'm dividing it by the new power, which is going to be 3 plus 1. Same thing again. 8x to the power of 2 plus 1 divided by 2 plus 1. Negative 75x to the power of 1 plus 1 divided by 1 plus 1. Now for the integral of a constant is always going to be the variable. So in this case, the variable is x. So it's going to be negative 50x. You just add the variable. You just multiply the variable with the term. If you remember in differentiation, when you differentiated a constant, it would give us a 0. But in integration, you attach a variable with the term. And since they haven't given us any limits for the integration, so you always add a constant. If the limits are given, you don't add a constant. But if they're not given, you add a constant. You can write K, C, any alphabet, whatever you want to, but not an X. It has to be any other alphabet but X. So let's simplify it. 12x to the power of 4 divided by 4 plus 8x cubed divided by 3 minus 75x squared over 2 minus 50x plus k. Simplified, 3x to the power of 4 plus 8x cubed over 3 minus 75x squared over 2 minus 50x plus k. This is your integration. You will leave it as it is because they haven't given us any point which we can substitute in this expression, find the value of k. So this is your final answer. Then the next question says the triangle ABC is such that AB is 15 centimeters, AC is 25 centimeters, angle BAC is theta degrees, and area of triangle is ABC equals to 100 centimeters square. We have to find the value of sine theta. So first, let's draw the triangle. Since they didn't say it's a right angle triangle, so we draw a non-right angle triangle. A, B, C. AB is 15, AC is 25, angle A is theta, and area of triangle is 100 centimeters square. So this is again a continuation of what you learned in your IGCSE. When you have a non-right angle triangle, and in that non-right angle triangle, we have two lengths and the angle between them. In order to find the area, we use the formula area equals to 1 over 2 AB sine theta. So over here, they've given us the area, they've given us the two length, we have to find the angle between the two lengths. So nothing new so far, except for the integration, obviously that was new. But area equals to 1 over 2 AB sine of angle C. So over here, it's 100 equals to 1 over 2 times 15 times 25 times sine theta. That's going to be 100 times 2 over 15 times 25. So we simplify this. This becomes 3, this becomes 20, this becomes 4, this becomes 5. We're just simplifying this fraction. So we have 8 over 15, and that is your value of sine theta. That was part A. That's it. They don't want anything else. Then for part B, it says, given that theta is greater than 90, find the length of BC in centimeters to 3 significant figures. So for this, let's find the value of theta first. Sine theta is 8 over 15. So theta is going to be sine inverse of 8 over 15. Plug this in the calculator, and what you should get is 32.23 degrees. Now we know sine is positive in the first quadrant and the second quadrant. They have clearly said in the question that theta is greater than 90, which means this is the angle that we're focusing on. So theta is going to be 180 minus 32.23. You always measure the angle from the positive x-axis over here in anti-clockwise direction towards the line. So since we're going till here, this is the angle that we're focusing on. So that's going to be 180 minus 32.23, which gives us a value of 147.8. This is the value of theta based on the given restriction. Going back to our triangle, it's a non-right angle triangle. We have the value of the angle. They want us to find the length of BC. So once again, if you recall your IGCSE knowledge, when you have two lengths and the angle between them, and they're asking you to find the third length, we will use cosine rule. So cosine rule is going to be BC squared equals to 15 squared plus 25 squared minus 2 times 15 times 25 times cos of 147.8. That gives us a value of 1484.64. This is BC squared, so to find the value of BC, we square root both sides, and that equals 38.5 centimeters. They want the answer correct to 3 significant figures. So that's your answer. Then it says the curve C has equation y equals to 5x cubed minus 8 over 2x squared, where x is greater than 0. We have to find dy by dx, writing your answer in simplest form. So now we're doing differentiation. And you were introduced with this concept in your IGCSE as well. So to differentiate, what we'll do is we'll first simplify this expression first. There are two ways to do it. Either you can use the quotient rule, or you can simplify it, rewrite it in a simpler form, and then differentiate it. If you don't know the quotient rule yet, so I'm going to suggest simplifying it. You break the fraction down into two fractions. It's going to be 5x cubed over 2x squared minus 8 over 2x squared. We split it into two fractions because both of the terms have the same denominator. Now we know 5x cubed divided by 2x squared is going to be 5 over 2 and then x in the numerator. Since 8 over 2 is 4, it's going to be 4 over x squared. This is your simplified equation, and now we're going to differentiate this. So as you know, for differentiation, we bring the power down and then we subtract 1 from the original power. So x has a power of 1. So 5 over 2 times x to the power of 1 minus 1. Over here, if we rewrite this, is going to be 4 times x to the power of negative 2. So you bring the negative 2 power down, multiply it by 4, and we subtract 1 from negative 2. So that's 5 over 2 because 1 minus 1 is 0, and x to the power of 0 is 1. So it's just 5 over 2 plus 8 x to the power of negative 3. You can rewrite this as a positive exponent as well, or leave it as it is. This is your differentiation for the given equation. Then it says the point P, 2, 4 lies on C. Find an equation for the tangent to C at P, writing your answer in the form of ax plus by plus c equals to 0, where a, b, and c are integers. Still like very simple, a continuation of your previous knowledge. So we know that in differentiation, if you have a curve and there's a tangent crossing it, like touching it, the gradient of the curve is the same as the gradient of the tangent. So gradient of curve is same as gradient of the tangent. So if we have the differentiation of the curve, we can use that to find the gradient of the tangent because they have given us a point that lies on C. And the tangent is also crossing through that point. So what we will do now is find the dy by dx at P. P is 2, 4. So you substitute x equals to 2, 5 over 2 plus 8 over 2 cube, which is going to be 5 over 2 plus 1, and that is 7 over 2. This is your gradient of tangent. We have a point that lies on the tangent. We have the gradient, so we can easily find the equation of the tangent. You can use point slope form, slope intercept form, any form you want to use for the equation. I'm going to use point slope form. So y minus 4 equals to 7 over 2 times x minus 2. 2y minus 8 equals to 7x minus 14. 2y equals to 7x minus 14 plus 8, which is going to be 7x minus 6. So they want the format as ax plus by plus c equals to 0. So that's going to be 2y minus 7x plus 6 equals to 0. That is your final answer. Then it says, in this question, you must show all series of your working. Solutions relying on calculator technology are not acceptable. So by substituting p equals to 2 to the power of x, show that the equation 2 times 4 to the power of x minus 2 to the power of x plus 3 equals to 17 times 2 to the power of x minus 1 and then minus 4. Can be written in the form 4p squared minus 33p plus 8 equals to 0. And then we have to solve the equation. So this is again similar to, if you remember your indices questions, the end questions, the harder ones. It's similar to that. You have to convert it into the same prime factor base first. That's the first step. And then you have to substitute p in the equation somehow, because p is 2 to the power of x. So it's not very complicated. It's still very easy to understand. So we have 2 times 4 to the power of x minus 2 to the power of x plus 3 equals to 17 times 2 to the power of x minus 1 minus 4. First, let's rewrite 4 to the power of x as 2 to the power of x and whole square. I'm going to split 2 to the power of x plus 3 into 2 to the power of x times 2 cube. If you remember, when we have similar bases being multiplied, we add the powers. So a to the power of m times a to the power of n is a to the power of m plus n. We're doing the reverse now. We're splitting it into the bases. So 2 to the power of x plus 3 is 2 to the power of x times 2 cube. Similarly, over here, 2 to the power of x minus 1 is 2 to the power of x divided by 2 to the power of 1. When similar bases are being divided, we subtract the powers. So again, we're doing the opposite now. So replace 2 to the power of x with p. 2 cube is 8. P over 2, and we have minus 4. Now that we have p in the equation and 2 to the power of x is gone, we're going to simplify this and convert it into the given form. 2p squared minus 8p equals to 17p over 2 minus 4. Multiply all of the terms with 2 to get rid of the fraction. 4p squared minus 16p equals to 17p minus 8. Collect the terms on one side. 4p squared minus 16p minus 17p plus 8 equals to 0. That's going to be 4p squared minus 33p plus 8 equals to 0, which is exactly the same form given the question. So this is your answer to part A. Then for B, we have to solve it. So for solving, we're going to use the P equation, not the X one, because the P equation is going to be easy to solve. So we have 4p squared minus 33p plus 8 equals to 0. You know how to factorize a quadratic equation because you've already learned that in your IGCSE. You can use the quadratic formula or splitting the middle term, even completing square, whichever method is easy for you to understand. I'm going to use splitting the middle term. 4 times 8 is 32. Factors of 32 that we can use over here to replace 33 is 32 and 1. So 4p squared minus 32p minus p plus 8 is 0. Now we do factor by grouping. In the first two terms, we have 4p common. So we have p minus 8 in the bracket. In the last two terms, we have negative 1 common. Again, p minus 8 in the bracket. So p minus 8 bracket 4p minus 1 equals to 0. P is equal to 8. P is equal to 1 over 4. Now we know p is equal to 2 to the power of x. And we're trying to find the value of x because they want us to solve the original equation. So we're going to replace p with 2 to the power of x in both the equations. So we know 8 is 2 cube. So when we have the same basis on both sides of the equal to sign, the powers are equal. X is 3. Over here, it's 1 over 2 squared. So that's going to be 2 to the power of negative 2. So x is going to be negative 2. These are your two values of x. That's your answer. Then in question 5, in this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable again. So we have the straight line L1, shown in figure 1, which passes the points P and Q. They've given the coordinates. We have to find the equation of L1, giving your answer in the form of y equals to mx plus c, where m and c are constants to be found. Once again, a continuation of your IGCSE. So far, the only new concept you've learned is integration. And in the previous question, like how to replace 2 to the power of x with p. Even though that's also not entirely new, it's very similar to what you've learned in the past, but the only new thing was integration. So we'll use what we know about how to find the equation of L1. We have 2 points, so we're going to find the gradient first. So M1 is going to be 6 minus 9 over 10 minus negative 2, which is going to be negative 3 over 12, and that's negative 1 over 4. That is the gradient of L1. Now we can once again use point-slope form or slope-intercept form to find the equation. If I use point-slope form, we can use any point. So if I use y minus 6 equals to negative 1 over 4 times x minus 10. Cross multiply, 4y minus 24 equals to negative x plus 10. So that's 4y equals to negative x plus 10 plus 24, negative x plus 34. Y is going to be negative x over 4 plus 34 over 4, and we can simplify the 34 over 4, is going to be 17 over 2. So this is your equation in slope-intercept form, where m is negative 1 over 4 and c is 17 over 2. Then it says the straight line L2 passes through the origin O and is perpendicular to L1. The lines L1 and L2 meet at the point R as shown in the figure 1. Find the coordinates of R and then the exact area of triangle OPQ. So we have the equation of L1. We need to find the equation of L2, solve them simultaneously, and we'll have the coordinates of R. As you've learned in your IGCSE, that when two lines are perpendicular, the product of the gradients equal to negative 1. So M1 times M2 is always going to be negative 1. We have M1, which is negative 1 over 4. So if we use that in this equation, we can find the value of M2. So negative 1 over 4 times M2 equals to negative 1, which means M2 is going to be negative 1 times 4 over negative 1, which is positive 4. This is your gradient of L2. As told in the question, the line is passing through the origin, which means the point we'll use over here is 0, 0. So y equals to 4x plus c. Put y equals to 0 and x equals to 0 to find the value of c, which is 0. Hence, your equation is going to be y equals to 4x. This is L2 equation. Now we solve this simultaneously to find the value of r. So previous equation was y equals to negative 1 over 4x plus 17 over 2. This was L1 equation. So put them equal to each other because they share the same value of y and x, which is the coordinate of r. So 4x equals to negative x over 4 plus 34 over 4. 16x equals to negative x plus 34. 16x plus x equals to 34, which is 17x. So x is going to be 2. So then y is going to be 4 times 2, which is 8. You can put x equals to 2 in either of the equations. Both will give the same answer. So coordinates of R are 2 and 8. Now for the area of the triangle, this is 2, 8. They want the area of the triangle OPQ. So if we connect this over here, PQ is the base of the triangle and OR is the height of the triangle. So you're going to find the distance of PQ and OR and then use that to find the exact area of the triangle. So for part C, distance of OR is going to be root of 2 square plus 8 square, which gives us root of 4 plus 64, and that's root 68. Then PQ is going to be root of 9 minus 6 square plus negative 2 minus 10 whole square. That's 3 squared plus negative 12 whole square, which is going to be 9 plus 1, 44, and that's root of 153. Prime factorize that, and that gives us 3 root 17. Area is going to be 1 over 2 times OR times PQ. Like we said, OR is the height and PQ is the base. So that's 1 over 2 times root of 68 times 3 root 17. Root 68 can be rewritten as 2 root 17. So replace that. So you can see that the 2 is getting cancelled out. Root 17 times root 17 is 17. So it's going to be 3 times 17, which is equal to 51 centimeters square. That is the area of triangle OPQ. So very basic, nothing complicated. Then it says figure 2 shows a plot of part of the curve C1 with equation y equals to 5 cos x, with x being measured in degrees. The point P shown in figure 2 is the minimum point on C1. State the coordinates of P. So you also learned about transformation of trigonometric equations in your igcse. So we have the equation of C1 as y equals to 5 cos x. We have to state the coordinates of P. So that's shown on the diagram. So we know in a cos graph, maximum value is 1, minimum value is negative 1. But over here, we have a transformation happening because we have a scale factor of 5 being multiplied with cos x, which means your minimum value is also going to get multiplied with 5, which makes this as negative 5 and this as positive 5. So your y coordinate is negative 5. For the x coordinate, we know this is 0, this is going to be 90, this is 180, 270, 360, 450, and then 540. We're adding 90 degrees in each square. So the coordinates of P are going to be 540 and -5. 540 degrees and -5. Once again, this is the same as transformation of trigonometric functions that you learned in your IGCSE. Then the point Q lies on a different curve C2. Given that point Q is a maximum point on the curve, it is a maximum point at the smallest x coordinate where x is greater than 0. So it's a positive angle, but it's the smallest one. Find the coordinates of Q when C2 has equation y equals to 5 cos x minus 2. So to the same graph, now we're moving 2 units down. There is a vertical translation happening. So if you're moving 2 units down, that means your y value is going to change. Y value is going to be 3 now. Nothing is happening to the x value because there is no horizontal translation happening or any transformation. It's just a vertical translation. So B1 is going to be y equals to 5 cos x minus 2. So 5 times 1, because you're talking about the maximum point, so maximum value of cos x is 1. 5 cos x is going to be 5 times 1, and then minus 2, which is 3. So the coordinates of Q for B1 are going to be 540, x is the same, y becomes 3. Then it says C2 has equation y equals to -5 cos x. Now, we're translating 5 cos x in the x-axis because the y value is becoming negative. So for B2, your original value for P, which is -5, that becomes +5. So y equals to -5 times cos x. So originally, if I draw the graph, this is 1, this is -1. First, I flip it, so it's going to be like this. So maximum value, which is originally 1, now it's -1. So I'm going to do -5 times -1, and that's +5. This is your y coordinate. Now for the x coordinate, we know that it's going to be greater than 0, but we know that it has to be greater than 0, but it's the smallest x value. So if we go over here, this was y equals to 5 cos x. If I flip it, and this, let's just draw. Okay, this is y equals to -5 cos x. It's translated in the x-axis. So now smallest x value is going to be 180 because this is our point Q. Y value is 5, so the smallest x value for y value being 5, where x is greater than 0, is 180 degrees. So Q is going to be 180 and 5. That is your answer. Then it says sketch the graph of the curve C with equation y equals to 4 over x minus k, where k is a positive constant. Show on your sketch the coordinates of any points where C cuts the coordinate axis and the equation of the vertical asymptote to C. Then given that the straight line with the equation y equals to 9 minus x does not cross or touch C, find the range of values of k. This one has a few new concepts to the question. So firstly, you know how to find the coordinate axis. For the x-intercept, you put y equals to 0, and for the y-intercept, you put x equals to 0. The vertical asymptote concept is slightly new. But if you remember functions, we've talked about it in functions when you have a rational function. For the restriction of domain, we always put the denominator equal to 0. And whatever value you get, your function does not exist on that value. So over here for the vertical asymptote, vertical asymptote. So denominator is equal to 0. So x equals to k. This is your vertical asymptote. Now for the y-intercept and x-intercept, we do for x-intercept, put y equals to 0. So y is 4 over x minus k. So when we put 0 equals to 4 over x minus k, when you cross multiply, x is getting cancelled out. And we're trying to find the x-intercept. So since x is getting cancelled, that means there is no x-intercept when y is 0. So no x-intercept. Now for y-intercept, put x equals to 0. So y equals to 4 over 0 minus k. That's 4 over negative k. So your y-intercept is 0 and negative 4 over k. So now we sketch this information. We have a vertical asymptote at x equals to k. And if we go to the question, it says that k is positive constant, which means it's not going to be on the negative side. So let's say this is x equals to k. Y-intercept is negative 4 over k. Since k is positive, negative 4 divided positive number is going to be a negative number. So let's say this is negative 4 over k. X equals to k is our asymptote, which means our graph cannot pass through this. And since there is no x-intercept, that means it's not going to cross the x-axis as well. So it's going to be like this. And then over here, it's going to be like this. It's not going to cross the x-axis. It's not going to cross x equals to k. It's going to be above or below it like this. So this is your graph for the given equation. Then they're saying, given that the straight line with the equation y equals to 9 minus x does not cross or touch C, find the range of values of k. So now we'll talk about discriminant. So when your curve and your line are not intersecting, that means there is no x value. Like there are no roots. So your discriminant is going to be less than 0. So b square minus 4ac is less than 0. So first let's create an equation. We have y equals to 9 minus x, and we have y equals to 4 over x minus k. We put both of them equal to each other, cross multiply. So that's going to be 9x minus 9k minus x squared plus x times k. Bring 4 on the other side. This is our equation. So since we're going to use b squared minus 4ac is less than 0, a is going to be the quotient of x squared, which is negative 1. B is going to be the quotient of x, which is going to be 9 plus k, because we have two x's. So when we take that x common, it gets multiplied with 9 plus k. And c is going to be negative 9k minus 4, which is our constant value. So b squared minus 4ac is less than 0. 9 plus k squared minus 4 times negative 1 times negative 9k minus 4 less than 0. 9 plus k whole square is going to be 81 plus 18k plus k squared plus 4 times negative 9k minus 4 less than 0. K squared plus 18k plus 81 minus 36k plus 16 is less than 0. So k squared minus 18k plus 65. 65 is less than 0. So now we factorize this quadratic inequality. Factors of 65 which we can use to replace 18 are going to be 13 and 5. K square minus 13k minus 5k plus 65 is less than 0. Between k and 13k we have k common. K minus 3 in the bracket. Between 5k and 65 we have again 5 common. Between 5k and 65 we have 5 common. So negative 5 bracket k minus 13. So k minus 13 bracket k minus 5. So if you remember from igcse, we have done quadratic inequalities and how to find the values of the variable. So you're solving quadratic inequalities. Once you factorize it, you just draw a rough graph with your intercepts. So we have 5 and 13. If the inequality is less than 0, we focus on the values underneath the x-axis. So this is where our focus is going to be. Like we will focus at the behavior of k equals to 5 and k equals to 13 underneath the x-axis. If it was greater than 0, we would look at the behavior of the values above the x-axis. So over here at k equals to 5, the values of k are decreasing. So over here at k equals to 5, the values of k are increasing, and at k equals to 13, the values are decreasing. So since they're converging, it's going to be joint inequality where k is less than 13 but greater than 5. That is your final answer. Then it says figure 3 shows a sketch of the plan view of a platform. The plan view of the platform consists of a sector DOC of a circle center O joined to a sector AOBEA of a different circle also with center O. Given that angle AOB is 0.8 radians, so this is 0.8 radians. Arc length CD is 9 centimeters. DA is to AO is 3:5. Show that AO is 7.03 meters to 3 significant figures. So we know the arc length of the sector, we know the angle, so we can use this information to find the radius. So over here, there's going to be a different formula because this is radians. So we know DA is to AO is 3:5. So using the arc length formula, which is arc length equals to R times theta. Now this formula is used when your angle is in radians. The formula you remember from IGCSE is going to be theta over 360 times 2 pi r. But in that case, the angle was in degrees. Now since it's in radians, we're going to use r times theta. So 9 equals to r times 0.8. 9 divided by 0.8 equals to r. That gives us a value of 11.25 centimeters. Now this is your radius of the sector. Not the circle, the sector. So we know that DA is to AO is 3:5. This is basically DO. DO is R, which is 11.25. So to find AO, we're going to use the ratio method, going to create a fraction out of the ratio. For AO, it's going to be 5 out of 8 and times that by 11.25 because AO is 5/8 of DO. So that's going to give us a value of 7.03 correct to 3 significant figures. So that's also shown in the question. Then it says find the perimeter of the platform in meters to 3 significant figures. For the perimeter, we need the length of DA, which is the same as CB, and we need the major arc of the circle AEB. So for the major arc, we need the major angle. That is going to be 2 pi minus 0.8. And then using that, we can find the arc length, and we already know the length of AO, which is 7.03. So 7.03 is the radius of the circle. We find the arc length, we find DA, CB, and then we have the perimeter once we add all of the information. So let's start. So firstly, we start with the major angle AOB. That's going to be 2 pi. 2 pi is 360, so in radians it's 2 pi minus 0.8, which is 5.48 radians. So major arc is going to be r times theta, where r is 7.03 and theta is 5.48. That equals to 38.52 meters. DO is going to be, DA is going to be 11.25 minus 7.03, which equals to 4.22. So the perimeter is going to be 9 plus twice of 4.22 plus 38.52. That's going to give us a value of 55.96 meters. They want us to round it correct to 3 significant figures. So that's going to be 56.0 meters. That's your answer. Then in part C, they're asking us to find the total area of the platform, giving your answer in meters squared to the nearest whole number. So for the area, we once again find the area of the major chunk of the circle, and then we find the area of the sector, and then we add the two. So for the area, we're going to use a different formula again because we're using radians, not degrees. Area is 1 over 2 r squared theta of the sector. So A1 is going to be 1 over 2 times 11.25 squared times 0.8. This is for the sector. That's going to be 50.625 meters square. Then the area of the sector from the circle, that's going to be 1 over 2 times 7.03 squared times 5.48. That gives us a value of 135.41 meter square. So we add it up. So 135.41 plus 50.625, and that gives us a value of 186.035 meters square. So nearest whole number is going to be 186 meters square. That is your answer. Then question 9 says the curve C1 has equation y equals to f of x, given that f of x is a quadratic expression. C1 has a maximum turning point at 2 and 2 at 220. C1 passes through the origin. Sketch a graph of C1 showing the coordinates of any points where C1 cuts the coordinate axis. So it's a quadratic expression. It has a turning point at 220. It's a maximum turning point. If you remember from your IGCSEs, y equals to negative a times x minus h whole square plus k is going to be your equation for a maximum quadratic curve. A maximum quadratic curve looks like this, where this is going to be your maximum points. Over here, this is 2 and 20. According to the question, it passes through the origin. So if I remove this line, so this is our curve. We know that h and k are 2 and 20, so y equals to negative a times x minus 2 squared plus 20. Then, to find the value of a, which is the scale factor with which the curve is being multiplied, we're going to substitute the coordinate 0, 0 because the curve is passing through the origin. So 0 equals to negative a times 0 minus 2 square plus 20. 0 equals to negative a times negative 2 square plus 20. Negative 20 equals to negative a times 4. Negative 20 divided by negative 4 is a, and that is 5. So y equals to negative 5 times x minus h whole square plus k. That is your equation. So we're going to use this information to sketch it. It's passing through the origin. This is our turning point, 2 and 20. This is 0. This is all of the information we have. To find the other x-intercept, what we can do is we can put y equals to 0. So 0 equals to negative 5 times x minus 2 squared plus 20, and find the other x-intercept. That's negative 20 equals to negative 5 times x minus 2 squared. 4 equals to x minus 2 squared. Square root both sides. That's plus minus 2 equals to x minus 2. So x equals to 2 plus 2, which is 4. That is the other intercept. Because the other one is negative 2 plus 2, that's going to be 0. We already have that. So the other x-intercept is x equals to 4. So this is your graph. Then, final expression for f of x, we already did that. That's going to be f of x equals to negative 5 times x minus 2 whole square plus 20. That is your expression. Then, the curve C2 has equation y equals to x times x squared minus 4. Curve C1 and C2 meet at the origin at the points P and Q. Given that the x-coordinate of the point P is negative, using algebra showing all stages of your working, find the coordinates of P. So since they're both meeting, that means they're intersecting. So we put both the equations equal to each other and solve them to find P. So that's going to be y equals to x times x squared minus 4. And then y equals to negative 5 times x minus 2 whole square plus 20. So x times x squared minus 4 equals to negative 5 times x minus 2 whole square plus 20. Expand the bracket. X cubed minus 4x equals to negative 5. Expand the bracket. X squared minus 4x plus 4 plus 20. So x cubed minus 4x equals to negative 5x squared plus 20x minus 20 plus 20. X cubed minus 4x equals to negative 5x squared plus 20x. 20 minus 20 is 0. So move everything on one side. So x cubed minus 4x plus 5x squared minus 20x equals to 0. So that's going to be x cubed plus 5x squared minus 24x equals to 0. We can take x common. So x bracket x squared plus 5x minus 24 equals to 0. So x equals to 0. X squared plus 5x minus 24 equals to 0. Let's factorize this. So it's going to be x squared plus 8x minus 3x minus 24 equals to 0. X bracket x plus 8 minus 3 bracket x plus 8. X plus 8 times x minus 3. X is equal to -1 and x is equal to 3. They said that P has a negative x value, if I'm not wrong. Yes. So which means x is going to be -8 for P. So to find the y value, we put -8 into either of the equations. So if I choose y equals to x times x squared minus 4, we substitute -8. That's going to be -8 times 64 minus 4, -8 times 60, and that's going to be -480. So P is -8 and -480. That is your coordinate for P. Then the last question says that in this question, you must show all stages of your working. So curve C has equation y equals to f of x where x is greater than 0. Given that point P, 8 root 2 lies on C. The first derivative of x is 4 root of x cubed plus k over x squared, where k is a constant. Second derivative is equal to 0 at P. We have to find the exact value of k first. So to find the exact value of k, I'm going to differentiate the first derivative again, put that equal to 0, plug in x equals to 2, and that will help us in finding the value of k. So let's start with this. The first derivative is 4 root of x cubed plus k over x squared. I'm going to rewrite this to make it easier for us to differentiate. The root of x cubed is the same as 3 over 2, so that's the power. And bring the x squared in the numerator, it becomes x to the power of -2. Now we differentiate this. Bring the power down, subtract 1 from the power, again bring the power down, and subtract 1 from the power. That's going to be 6x to the power of 1 over 2 minus 2k x to the power of -3. Put this equal to 0 and substitute x with 2 because that is the x value at P. So that's going to be 6 root 2 minus k over 4. K over 4 equals to 6 root 2. K is going to be 24 root 2. After that, it's saying find f of x giving answer in simplest form. So to find f of x, we're going to integrate the first derivative because we're going backwards now. So firstly, let's write our first derivative equation with the value of k, which is going to be 4 root of x cubed plus 24 root 2 over x squared. Now we're going to integrate this. So 4 x to the power of 3 over 2 plus 24 root 2 times x to the power of -2. As we know, we add 1 to the power and then divide the term by the new power. So 4 times x to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 plus 24 root 2 times x to the power of -2 plus 1 divided by -2 plus 1. And then plus c, because we don't have a limit, So we're going to add a constant, which is going to be 8 over 5 times x to the power of 5 over 2 minus 24 root 2 over x plus c. This is our integral and f of x right now. To have the complete equation for f of x, we need to find the value of c. So for that, we will put point P in this equation because point P lies on the equation of the curve. So P was 2 and 8 root 2. So 8 root 2 equals to 8 over 5 times 2 to the power of 5 over 2 minus 24 root 2 over 2 plus c. 8 root 2 equals to 8 root 5 times root of 32 minus 12 root 2 plus c. Let's prime factorize root 32. That is going to be 4 root 2. So that gives us 8 root 2 equals to 32 root 2 over 5 minus 12 root 2 plus c. Multiply everything with 5 to get to the fraction. So 40 root 2 equals to 32 root 2 minus 60 root 2 plus c, which is going to be 40 root 2 plus 28 root 2. So this is going to be 5c. So equals to 5c, which is 68 root 2. Divide that by 5, and that's the value of c, which means f of x is going to be 8 over 5 times x to the power of 5 over 2 minus 24 root 2 over x plus 68 root 2 over 5. That is the equation of the function, and with that, we're done with paper 1. If you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos which I'll be uploading in this playlist.